talk about how to graph a function without using calculator. So the first thing that we came up with is we're going to be graphing f of x equals -4 times the cube root of x plus 2. We need to identify the parent function because at least with the parent function we have a couple key points in our mind. At least I hope. So when we look at this one, our parent function is f of x equals the cube root of x. What we want to do on this first graph is we want to draw in that function. If you've forgotten what the key points are on this one, it's 0, 0, 1, 1, 8, 2. I know I have more than what you had to remember. 8, 2, -1, -1, and -8, -2. One of my favorite ones, actually. I don't know why. But once we determine what the parent function is, then the next thing that we want to do is we want to look at the transformations. And in this particular graph, there's 3 transformations. And our first transformation is going to come from the fact that there is a negative in front of the function. What does a negative in front of the function do to the function? We reflect over the x-axis. So I just wrote that up a little bit higher so I could fit it in. I didn't have to squeeze it in. So now, what happens if we reflect over the x-axis? What's above the x-axis is going to go below the x-axis from our parent graph. And what's below the x-axis is going to go above the x-axis in our parent graph. And I usually use a hand gesture to flip that. I go like that with my hand, which I know you can't see on the video, but I flip my hand over and it kind of flips over the graph in my mind. So that's the kinesiology behind this. But ultimately what's going to happen is we're going to have still the point 0, 0. But the point 1, 1 is going to become the point -1, 1. The point 8, 2 is going to become the point 8, -2. The point -1, -1 is going to become the point -1, +1. And the point -8, -2 is going to become the point -8, +2. We flip everything around. So 0, 0, 1, -1, still can't get that. 8, -2. -1, +1, and -8, +2. So here's the first part, and actually if you would look at my notes, I don't even connect the points, but there is the reflection over the x-axis. So now, what we want to do is we're going to look and see what's the next thing that happens to our graph. And the next thing, for lack of better math words, is that 4, which is still in front of the function. And what does a 4 that's outside of the function do to our function? Well, what it does is we're going to vertically stretch our graph, and it's going to be by a factor of 4. And when we graph this point here, we're going to start with 0, 0. And the part that's going to stretch is the part that's going to be a y value. So in this case, what happens is, from our blue graph now, we have 1, -1. Well, that meant we went right 1, and then we went down 1 space. The vertical is coming from the up or down part of it. So instead of 1, -1, we're going to do 1, -1 times 4. So we're going to come over 1, still to the right, following here, But instead of going down 1, we're going to go down 1, 2, 3, 4. Negative 1 times 4. So I know that's new for us. So let's look at that again. Our next point on the graph is 8, negative 2. We're going to go 8 spaces to the right. That's a horizontal. And then we're going to go down 2 spaces. That down 2 is the vertical part. It's the y value. We're going to take negative 2, and we're going to multiply it by 4. So now we're going to come over 8 spaces, but negative 2 times 4 is negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Now the thing is, Grace, I couldn't hear you. But this distance is 2. So if you take 2 times negative 4, then now the distance is going to be 8. This one is 1, negative 4. And this one's going to be 8, negative 8. Negative 2 times 4. Look at this vertical distance. This vertical distance here is 1. So then we take that value, that vertical distance of 1, in case at this point it's 1, negative 1. The y value of that ordered pair gets multiplied by the 4. That's the stretch part. So this point here, 8, negative 2, the y value in that point is the part that gets stretched by 4. That's the negative 2 times 4. Chloe? And if it's a horizontal stretch or shrink, then we're going to change the x value in the point. This is 8, negative 8. So it's going to be the same thing over here on the other side of the y-axis. Here we have this point, negative 1, 1. The negative 1 isn't going to change. It's going to be the positive 1. It's going to be the y value of that ordered pair. Positive 1 times 4, this becomes negative 1, 1, 2, 3, 4. And our last point on the graph was negative 8, 2. Well, it's the y value. It's a vertical stretch. So right now, our y value is 2, and 2 times 4 is 8. So this is going to be negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's only our second transformation here. Again, you do not have to really connect the points. Really what we're looking at is this last one. There's nothing wrong with it. Because then the last transformation is the plus 2. How does the plus 2, which is outside of the function, change your function? Not right. Or it's up 2. Because the right and the left is going to be an inside of the function, and plus 2 is outside the function. So now what we're going to do is we're going to take all of our values on our graph, and we're going to move them up 2. So remember, this was negative 8, 8. So now it's going to be negative 8, 10. And our second point on our graph was negative 1, 4. Now it's going to become negative 1, 6. 0, 0's still going to nope. 0, 0 is going to become 0, 2. 1, negative 4 is going to become 1, negative 2. And 8, negative 8 is going to become 8, negative 6. And there's our graph. That's the first one that you've ever seen. If you kind of sort of understand it, good. This isn't going to be a topic where you necessarily understand everything there is to know about it on the first example, which is why I have a few. But I hope that you kind of sort of have the idea. As we look at the next example, once again, what we want to do is we want to identify what's the parent function. Well, our parent function here, oops, I skimmed that all together. Our parent function this time is going to be the x cubed function. So if we look at this graph in terms of the points, this is the inverse of the function that we just worked with. Chloe? Well, but just right now we're just doing the parent function, and then the negative and the 1/3 are transformations to it. But we're going to start with the most basic of the functions, the x cubed. And that has the points 0, 0, 1, 1, 2, 8, negative 1, negative 1, and negative 2, negative 8. There's our picture of our graph. And then we need to identify the different transformations. So when we do the negative, first of all, this negative inside the function, how does that change our function? This time we're going to reflect over the y. So what's going to happen is that the 0, 0, it's not going to change. If only. 0, 0 is not going to change. But the point 1, 1 is going to reflect over the y. So it's going to go to negative 1, 1. From this negative. Just because it's inside. Good questions. So there's the negative 1, 1. The 2, 8, remember, we're going to flip that over the y-axis. So it's going to become negative 2, 8. But we also have the values of negative 1, negative 1. If we flip that over the y-axis, we're going to have 1, negative 1. And negative 2, 8, we're going to flip over the y-axis, and we're going to get positive 2, negative 8. There's our reflection over the y-axis. So now, the next transformation in our graph has to do with the 1/3. The 1/3 is inside the function. What does inside the function, the 1/3 inside the function, do to the function? Well, remember, if you look back at your chart, what we have to do is we have to take the reciprocal of 1/3, which is 3, and inside the function is going to be a horizontal change. So this is going to be a horizontal stretch. It's going to be by a factor of 3. The 3 comes from taking the reciprocal of 1/3. We flip that fraction. So now we're going to stretch it. And as Chloe pointed out earlier, now the x values are going to change. 0, 0 is not going to change. 0 times 3 is still 0. But when we look at our next point here, which is 1, negative 1, the negative 1 part isn't going to change. It's going to be the x distance that's going to change, the horizontal distance. So we went over 1 space, but now we're going to have to take that distance of 1 space and multiply it by 3. So we're going to have to go 1, 2, 3, down 1. The x value, 1 times 3. Our next point was 2, negative 8. But instead of going a distance of 2 spaces, we're going to go 2 times 3, which is 6. Our negative 8 distance isn't going to change. We could also do that with the other side of the graph. Negative 1, 1. Negative 1 times 3 is negative 3. Our vertical distance isn't going to change. And our last point on the graph was negative 2, 8. Negative 2 times 3 is negative 6. And the vertical distance still doesn't change. It's still 8. So there's our second transformation. And we've got one more. Minus 4 is outside of the function. How does minus 4 transform our function? We're going to go down 4. So on this one, once we've got the green graph, all that we're going to do is we're going to move each of those points down 4. So negative 6, 8 becomes negative 6, 4. And negative 3, 1 becomes negative 3. And then 4. Is it negative? Sorry. 1, 2, 3, 4. Negative 3, negative 3. And down 4. 0, down 4. 0, negative 4. And 3, negative 1. 3, negative 1 becomes 3, negative 5. And the next one will go off our graph, but 6, negative 8 becomes 6, negative 12. So it goes off our graph, but hopefully we get the idea here of what's happening to our function. Are we a little bit better this time? Like I said, this might not even be something that we're going to completely get today. We're going to spend pretty much the rest of the week practicing this kind of thing. So, as we look at the next problem there, and sorry about my numbers here, but this one's a little bit quicker, hopefully. And my graphs are a little bit better on this one. But when we look at this problem here, what's our parent function? 1 over x. So that's good. We can identify that. That's definitely a positive. And when we graph this, I'm going to graph, our main key points were the 1, 1. But I'm also going to graph the point 2, 1 half. 1 over 2. That's where I came up with that. And we get this branch. And then if we go the other direction, we've got 1, negative 1, negative 1, negative 1. But if we put negative 2 in there, we get negative 2, negative 1 half, just to give us a little bit more direction. But by the way, if you really sit back and look at this, I think that you can use symmetry to help you draw the graph a little bit. Once we get one part of the graph, don't you think we could get the other part of the graph with the symmetry? And maybe not. But we have two things happening here on our transformations. What does the negative in front of the function do to our function? This negative right here. There we go. Reflect over the x. When we reflect over the x-axis, then 1, 1 is going to become 1, negative 1. And 2, 1/2 is going to become 2, negative 1/2. And we get this branch. And the same thing's going to happen with our other branch. Negative 1, negative 1 is going to become negative 1, positive 1. We're flipping that over the x-axis. And negative 2, negative 1/2 becomes negative 2, positive 1/2. So there's our reflect over the x-axis. And finally here, the x plus 3. What does that plus 3, how does that plus 3 transform our function? We're going to go left 3. So when we move our graph, we're going to move our points here, everything 3. So 1, negative 1 moves over here to 3. So how about I move it the correct direction here? 1, negative 1 moves 1, 2, 3. So negative 2, negative 1. And 2, negative 1/2 goes to negative 1, negative 1/2. And we get this branch. And we're going to continue moving it over here. 1, 1 moves left 3. 1, 2, 3. So it's going to be at 4, negative 4, 1. And our negative 2, 1/2 moves left 3. So it's going to be at negative 5, positive 1/2. And we get our graph there.